I'm getting feedback here. So this is the mirror. Then light from the source incident on the mirror. So this is the incident ray from the source. Once there is incident ray, there will be reflection. So once there will be a reflected ray, we must get a normal because angle of incidence will be measured. So will be angle of reflection. So this is N1. Because angle of incidence I must be equal to angle of reflection let's draw the reflected ray produced by the mirror at this position. So this becomes R1, reflected ray 1, and its value is also equal to I. This is because angle of incidence is equal to angle of reflection. Now this mirror is rotated through an angle theta. The rotation can be clockwise or anti-clockwise. So I'm rotating it clockwise. It was like this, and I'm turning the mirror through an angle. So this is now the mirror position. It is rotated through an angle alpha. Now, under rotation of a mirror, we don't change the source of the light. The reason is that the source of light can be a bulb somewhere or the light ray coming from the sun. How would you go and then change the position of the sun or the bulb? So we usually, under this concept, we usually keep the incident ray fixed. But the reflected ray, before rotation and after rotation, is what changes. Let me get a mirror to demonstrate something for you. Look at this position of the mirror. I think you could see a reflected light being reflected to the screen, correct? Class?
Yes, sir.
Good. I'm going to try and then change the position or rotate it. And let's see if what you are perceiving as the reflected ray is the same. So when it is like this is a reflection. When I rotate the mirror, are you still seeing the reflected ray? Are you?
No, please.
No.
So let me take it again. When the position is like this, I think you are seeing reflected ray from the light around. Once I turn or rotate the mirror, the reflected ray position has changed. You are not seeing it again. Is that it? Good. What it means is that when you rotate a mirror, the reflected, by virtue of the rotation angle, the reflected ray also changes. So this is the red line is the new position of the mirror after the rotation. If that is it, then we'll have another reflected ray. So the incident has not changed. But after rotation, the normal would also change because the normal goes with the position of the mirror. N1 is the position when it was horizontal, 1. So N1 indicates the normal at this position 1. When it is rotated, representing the red line, the normal would also change because the normal must always be perpendicular to the surface. So I'm drawing another normal to the new position of the mirror. So I have the black line representing the second normal after rotation. So N2. N2, I think the reflection. So N2. After the rotation. Then, so the new angle of incidence here will be from the incident ray to the new normal. This will be the new angle of incidence. Okay. The reflected ray to after rotation must also be equal to the angle of incidence. So the new reflected ray also becomes from the same spots to this position. So this becomes R2. The 2 indicates after reflection. Now, another important concept, pay attention and listen. I'm going to demonstrate that, so listen. Whenever you rotate a mirror, the angle between, look at the angle between, this is the first normal position, N2, when the mirror is not rotated. So the pencil is on the initial normal. When you rotate the mirror through an angle theta, I'm taking it again. The pencil is on the initial normal, and I'm rotating the mirror through an angle alpha. The ruler is on the new mirror position. The angle between the two normals is equal to the angle of rotation. The mirror is rotated through an angle alpha. And look at how the normal position also changes. The old normal, I'm rotating the mirror. The mirror is the ruler. through the angle alpha. And look at how the normal will also change. Okay. The pencil now is on the new normal, meaning when you rotate the mirror through an angle alpha, the angle between the first normal and the second normal also changes by the same margin, alpha. So when you rotate the mirror 15 degrees, the angle between the first normal and then the second normal is also 15. Please, is that okay? Hello, class, is that okay?
Yes.
Good. Now, Bridget, on the stairboard. I'm coming. Okay. So now, so this is alpha. Initially, this is I. I want you to help me determine after rotation, what is the angle? What is the new angle of incidence? Assuming the source is S. So we are looking for angle, and this point is O. We are looking for angle S, O, and 2. I mean this whole angle after rotation. If this is I, and the angle between the old normal and the new normal is alpha, what do you think will be the angle between S, O, and 2? Angle S, O, and 2. Can somebody help me? Yes, Audrey.
Say please, I plus alpha.
So this is I plus alpha. Thank you. So after the rotation of the mirror, the new angle of incidence is equal to I plus alpha. Then it means angle of incidence equals angle of reflection. So angle N2OR2 is also equal to I plus alpha. From angle of incidence equals angle of reflection point of view. Now, all that we want to see under rotation of mirror is what is the angle between the reflected rays, R1 and R2? So we are looking for angle R1 O R2. Now angle R1 O R2 is part of a bigger angle N2 O R1. So we could see that angle N2 O R2 is equal to angle N2 O R1 plus angle R1 O R2. So N2 O R2 is a bigger angle, which is actually this. So if we want to determine out of this, let's make angle R1 O R2 the subject. And this is equal to angle N2 O R2 minus angle N2 O R1. So we are only making this angle from this equation. Okay. Now, if angle N2OR2 is equal to I plus alpha, it means that we must get this one to subtract from this to get angle R1OR2. I want you to think through and see if you can. Let's determine angle N2OR1, N2OR1, and subtract it from angle N2OR2. And that would give us this angle we are looking for. Au revoir.
Stadium, please, can you come in?
We are looking for the angle between R1 and R2. And that is what is being termed as angle R1 O R2. But we know that this angle is part of a bigger angle, and the bigger angle is N2OR2. So it is this plus this. So if we could get a bigger angle and subtract the smaller angle N2OR1 from it, then we can get this angle, which is indicated by the question mark. So my issue is that angle N2OR2 is this, I plus alpha. What will be the smaller angle? N2OR1. So that we can just subtract it from the bigger one to get R1OR2. That's my question. Mamiya.
Please, angle N2OR1 would be I minus alpha.
Why?
Because N2OR1, no, NOR1 was I. And then when it was rotated by an angle alpha, it was shifted. So you remove alpha, you subtract alpha from I to get the new angle.
Okay. Do we have any different opinion? If you are seeing something differently, share that with us. Or if you agree with what Mamiya said, let me know. This is what she's saying. Angle N1 OR1 is I. When the mirror isn't rotated, angle of incidence equals angle of reflection. So this, she's saying that this bigger angle is I. And the angle between the two normals, N1 and N2, is alpha. So if you are looking for this, subtract alpha from I. And that is true. So it means that this is also I minus alpha. I want you to simplify this for me. I plus alpha minus I minus alpha into brackets. Mamiya.
Please, it should be 2 alpha.
So when you expand, Caleb.
Sir, please. I was about to answer the question.
Okay. Go ahead.
If we simplify I plus alpha minus in a bracket I minus alpha, we would get I plus alpha minus I plus alpha, which would give us 0.
No, look at it again. You have to multiply through by the negative outside the bracket.
You get I plus alpha minus I plus alpha. It will get 2 alpha.
Exactly.
2 alpha.
Yes. So this will be equal to 2 alpha. Alpha, we know. What is alpha? What is alpha? Alpha is equal to the angle of rotation of the mirror. What we have actually learned is that whenever you rotate a mirror, and then the angle of the incident ray is kept constant. The angle of rotation, the reflected rays, the old reflection, and then the new reflection also changes by an angle which is twice the angle of rotation. So the concept that is learned is that whenever a mirror is rotated, through an angle theta, when a mirror is rotated through an angle theta, the angle between the reflected rays, is always twice the angle of rotation of the mirror. Rotation of the mirror. So when you rotate the mirror by x, the angle between the reflected rays would also be 2x.
Sir, please, I can't see.
Let me change the marker.
Sir,
So let me read it so that you put that down. Okay. What I'm saying is that the concept we have learned is that whenever you rotate a mirror through an angle theta, the angle between the two reflected rays, the first reflection and the second reflection, is equal to twice the angle of rotation. So whenever a mirror is rotated through an angle theta or alpha, the angle between the reflected rays is always twice the angle of rotation of the mirror. Okay. It's always twice the angle of rotation. Au revoir.
Mr. Fadia. Yes, please. Please. I wanted to ask for the angle N2OR2. The alpha behind, like, it's not part of the angle. So why are we adding it?
No, we are not. You see, angle N1OR1, the angle is I. In between this angle, in between I, we have angle N1ON2, which is alpha. N1 O N2. This is equal to alpha. This is equal to alpha. Then angle N1 OR1 is equal to this alpha plus this. But don't forget that, okay, don't forget that this whole angle is equal to I. N1 OR1 is I. And if this is alpha, then the river what will be N2 OR1.
You
If
say
this
they
is-
want to subtract.
Yes. And that's what we've done here.
By still plus.
No, it's I
Okay.
minus alpha. We've subtracted. Okay.
Okay. Then please out of the N2OR2. That's what I'm talking about, from N2 to R2.
N2OR2. That is the
Yeah.
new reflected angle of reflection.
I don't understand why we are adding the alpha.
You see, we mean N2OR2 is this whole angle. Correct?
Yes, please.
Good. This is from this point of view. Let me change the marker. When the mirror is rotated, this is the new normal. This becomes the angle of incidence. This becomes the angle of reflection. Angle of incidence is equal to angle of reflection. We determined the angle of incidence. We had I plus alpha.
Yes, please. Okay, I've now understood.
So if angle of incidence is I plus alpha, then angle of reflection will also be I plus alpha. All right.
Okay. Yes, please. I've understood.
Okay. So that is the concept length. The rest is about solving of questions. I'm coming in. They are contacting. Please give me a minute. I'm coming. Somebody. Sorry. We are back from commercial break. So this is the concept of rotation of mirror. Meaning sometimes instead of giving you the angle of rotation alpha, they will rather give you the angle between the reflected rays. Okay. They can rather give you the angle between the reflected rays and ask you to find the angle of rotation. Assuming that assuming you are told the angle between the reflected rays is beta, what will be the angle of rotation of the mirror? Assuming the angle between the reflected rays is beta, what will be the angle of rotation of the mirror?
Please, beta over 2.
Thank you. Thank you. So this is the key concept and the rotation of mirror. When you rotate a mirror, whether clockwise or anti-clockwise, when the source of light is kept constant, the angle between the reflected rays is twice the angle of rotation of the mirror. Any question? Any question? Class, any question? No question. Let's try applying this to solve a problem. And I'm going to send a question to you. I'm going to send a question to you. Evening, okay. I'm coming. So the angle of rotation of the mirror is 15. And the angle of incidence is 30. Find the angle between the reflected rays. So 5 minutes. Just make me proud. Let me reconnect the speaker. The mirror is rotated. And the angle of rotation is 15. If this is 15, then the new normal N2 would be here. So it means this will also be 15. This is angle of incidence. N2. So this is the angle of incidence after rotation. And so angle of incidence after rotation, angle of reflection after rotation would also be this. So this is R1. This is R2. Of course, we know R2 would be R2, R1 O, R2 will be 2 times 15. So the question is, what is the angle? Mamiya, hello.
Yes, please.
What is the angle between the reflected rays?
30 degrees.
30 degrees. Let me modify this question. Sometimes you will be asked to determine the angle from the incident ray to the reflected rays. Let me modify the question. The angle between the incident rays, the incident ray, and the reflected rays. Yes. How would you answer this? What is the angle between the incident ray and the reflected rays? Nana Safo, give me one of them.
Sir, please, why is the angle between the reflected rays 30 degrees? I don't understand that part.
Audrey, maybe your line dropped. Mamia. Mamia,
Yes, please.
can you explain it to him? I'm sure you heard his question.
Yes, please.
Explain to him.
The in the first sample that we took, it was angle N2 OR2 is equal to angle N2 OR1 plus angle R1 OR2.
Mamia, just talk about the final concept we developed.
Okay. The final concept was that the angle between whenever a mirror is rotated through an angle, which is alpha, the angle between the angle between the reflected rays, the two reflected rays, the R1 and the R2, is 2 times the alpha. So 2 times by the 15 is 30 degrees.
So the concept, Audrey, the concept is that whenever you rotate a mirror through an angle theta.
Sir, please.
Are you there? Audrey?
Yes, sir.
Whenever you rotate a mirror through an angle theta, okay, the angle between the reflected rays, Angel, you have the angle between the reflected rays. This is the first reflection before the mirror, okay, is rotated, and this is the second reflection after. So the angle between the two reflected rays is always twice the angle of rotation. So when the mirror is rotated by, let's say, an angle of 10 degrees, the angle between the reflected rays is 2 times 10, which is 20. So in this particular question, the mirror was rotated through an angle of 15 degrees, meaning the angle between R1 or R2 will be 30. Edric, are you okay?
Yes, sir.
Okay.
Yes,
so the new question now is that calculate the angle between the incident ray and the reflected rays, because we have R1 and R2. And don't forget, under rotation of mirror, we don't change the source, meaning the direction of the incident ray does not change. Okay, the Y I've told you. So calculate the angle between the incident ray and then the reflected ray. Mommy, are you done? Angel, are you done? Hello. Okay, so if you are not done, maybe 5 minutes to think through it. I'll be with you. Because of small work, you are quiet. Okay, Mamia, the usual mouthpiece of the class. Mamia, what have you had? Okay, and Caleb said, he said he had 90.
Please, I had 60 degrees.
The angle between the reflected rays, so from the incident ray to the reflected rays. So it isn't just an answer. Okay, let's pick it. And then you see, this is what I'm looking at. This is the incident ray. The angle between the first reflected ray is 1. The angle from the incident ray to the second reflected ray is 2. So you are to get 2 different angles between the incident ray and the 2 reflected rays. So you still have the opportunity to think through it, right? Caleb, is that 6? Oh, how can this be? Look at it again. So we mean, let me change the marker. Let me use the red marker too. The angle between the incident and the reflected ray. So I mean this one, and then this second one. This is the first reflected, this is the second. So this angle and then this angle is what you have to calculate for. Now, for the first one, obviously that will be, this is 30. This is 30. Angle of incidence is 30. This is also 30. So 60. The first one will be 60. Then the second one would be, Mamiya, the second one would be Mamiya.
Yes, please.
The first angle is 60. What about the second angle?
90 degrees.
90. Okay. So is the angle between the incident ray and the reflected rays. But don't forget, the mirror is rotated. So we have 2 reflected rays. So first one and then second one. All right. Class, are we okay? 38 of you, are you okay? 37. I'm taking myself out. Are you okay?
Yes.
Another example would come. The reason for which I want to be sure if you're okay. If you are okay, then...
Please, can you come again with why we have 60 and 90?
Okay, so the question is that find the angle between the incident ray and the reflected rays. Incident, which is this from the source, and then the reflected rays. So we are looking at the angle between the first reflection, this angle, then the second reflection, which is this angle. Okay, the angle of incidence is 30. Angle of incidence equals angle of reflection. So if this is 30, the other angle will be 30 as well. Meaning, before rotation, the angle between the incident and the reflected is 60. So this will be 60. Then, because we know the angle between the reflected rays is twice the angle of rotation, if this is 15, this is also 30. So 60 plus 30 would give us 90.
Yes, please.
This is 60 plus this 30 would give us the other angle between I and then the reflected rays. Wherever are you fine?
Yes.
Okay. All right. So if you are okay, then I think the next thing we have to do is spherical mirrors, because for plane mirrors we've gone through when 2 mirrors are inclined at any angle theta. We've also gone through formation of images in plane mirrors. Then we've done rotation of mirror, plane mirror. The next mirrors we need to look at is spherical mirror or curved mirrors. Okay, curved mirrors. So that's the next thing we'll be doing on Friday. Okay, so we have 8 minutes to time, but we'll end here. Please, the evaluation will be done on Friday. So, I mean, you can just open the link and then read through so that you decide on what to input on Friday. Until then, may the good Lord be with you. Take care of yourselves. And as usual, your assignment and then the video for the day will come. Okay? In fact, bye-bye. We'll continue on Friday. Please go to the YouTube channel like, subscribe, and share. I beg you. I need this so badly. Okay.
Sir, please, I've already subscribed though. I'm
So
Ghanaian
Udrick,
loaded.
and give it to your friends. Okay. Share and all that. Okay. And then pass a beautiful comment. Okay. Thank you. Your assignments will be uploaded within the day. Okay. And then the video. All right. Bye-bye.